So today I thought I'd start out my video inside the house before I go out in the shop and work. I have a repair that has to be made on a piece of cast iron, and it was previously repaired with brazing rod. And when you braze on something for a repair, there is no mingling of the materials. When you're welding, you are actually mingling it. When you are brazing, it's just laying a layer over the top. So what I'm going to do today is use my rod of choice for cast iron, which is a 7018 regular mild steel low hydrogen rod in a 332 diameter. We will do a preheat, the welding, tacking, and then do a post heat on it, and then it will go into some fiberglass insulation, and I will leave it until tomorrow to cool and continue the video tomorrow when I take it out of the bin that has the fiberglass insulation in it. That way it cools slowly so it doesn't end up cracking. Now you say, well, why would you use 7018 welding rod? Well, one of the main reasons is cost. What I always see when I weld on cast iron or cast steel is a lot of porosity. No matter what rod you use, you're going to end up with that porosity. With a cast iron rod, you have to do what's called buttering up. So you lay a pass on, and that pass mingles the two metals together, which is the metal from the cast iron and the metal from the welding rod. 580 is $80 a pound. Muggy Weld is really close to that. I'm sure Nyrod is realistically pretty close to that same cost because of the nickel that's in it. Where 7018, for 160 bucks, you can buy 50 pounds of 332 7018 weld rod. So there is a huge cost difference. It's going to have to be clamped down so that it stays solid, so that when you do the tacking and the welding process, that it all stays where it's supposed to be. Now, as you can see looking at these pieces, is it has a 5/8 hole in the center of it, and those holes are going to have to align. So I have a cleaned up piece of 5/8 round stock that I'm going to run through there and then remove it after it's completed before it cools down, so that I can put it in the fiberglass insulation and it will hold its shape afterwards, and the rod will be able to fit through afterwards. Other thing that needs to be done this morning is all of this has, as I said earlier, it's been repaired with brass brazing rod. So all of that brass or bronze has to be ground off, and then I need to grind a bevel into this so that I can get some penetration and some strength back in the piece when I am completed. Okay, all of the cleanup is pretty much completed and the beveling process is done. You have to get all of the bronze or brass filler rod off of there, or it's going to spit and sputter when you try to weld on it, because they're not going to want to mingle weld together at all. And then bevel back the sides. If you can get it from both sides, you're better off, because it'll keep everything straight. If you can weld one side, then switch over, weld the other side, then to the opposite side, and just keep going back and forth. That will keep the pieces straight and square as you want them. If you can't get to both sides, then you bevel one side and you take it in, so that when you run your first pass in there, you will get almost full penetration, but no matter what, you will not get full penetration. Something I did not tell you earlier in the video is that when you do this with 7018 welding rod, the remaining piece after it's completed is so hard that you cannot even touch it with a tap. So if you have threads, make sure that it's chased and clean and ready to weld, and then when you weld it, make sure that you do not get any spatter on those threads, because it will basically break a tap, it break the teeth right off of a tap when you try to tap it. So make sure whatever you do is ready and complete and you don't mess it up during the welding process. I'm sure a few of you are saying, why would you want to fix that piece of crap? Why not just make one out of steel? Which I could do. That's not a problem. In this case, the reason I'm doing it is for the video, but normally if you had this and it was maybe for an old tractor, or it was something for an old car that you wanted to keep it original and look the same as what it looked like from the factory from before, then you could take the time, which I'm not going to take that time, to make it perfect, and in that case it would look really nice and it would still be the original part. So looking at this right now, you can see that the rod is lined up, everything's clamped down on the bench where I want it, so I'm ready to do a preheat, and then I'm ready to tack this in position. I'm just going to set the torch down on the table and leave it set there while I tack pieces so that I don't have to relight every time in between. I want to get a tack on both sides of this so that it doesn't pull. I'm going to first get everything all up to a semi-warm temperature, because my workshop right now is not real warm. The table below, you can see, is creating condensation, so the table itself is not warm either. So I get everything up to a good general warm temperature. After I get it all tacked up, then I will pull the rod out and move forward with the welding portion, working from one side to the other so that it doesn't pull too much. Now I'm going to tack this side up first because I'm concerned about this side pulling down tight on this round stock, and then I wouldn't be able to get the round stock out. So now you want on your preheat, and pretty warm right there. So that's where I'll leave that at. Not liking the brazing rod. As you can see, I did not get it all off of there. Now I will go on and I will do a preheat on this side. No matter what you do, it's never going to be perfect. Just do the best job that you can do, and it will hold. spot where I touched the rod here where I'm not going to be able to get it through, so I'm going to have to hit the grinder and clean that up. A little bit tight, but that's the way it originally was, so that's what you want. Okay, the welding process is complete. Now I will do a post heat and then wrap it directly in fiberglass. Post heat actually relieves any stresses that the welding process made. Sorry about that, my hand bumped the oxygen and turned it way down. This piece is actually from a piece of woodworking equipment. The customer asked if I would fix it or build a new one. And I thought, well, you know, this would be a perfect video for anybody who had a piece of cast that wanted to do a repair on it. And say, like I said before, something that's older that you wanted to keep it original. Because I sure wouldn't go through this much work for this normally. And I'm giving a customer a break on the cost of this being as though it takes so long. But this is what it takes to repair cast iron. It's a time-consuming process, and you just gotta take your time and do it right, follow through on the process, and get it completed. Alright, I believe I've got plenty of heat in here for a post heat. And we'll grab one old piece of fiberglass. And I will wrap it in that piece of fiberglass. And then I have a bin that has a lot more fiberglass that I will be wrapping it into, so that when I come back tomorrow, it will be just as, it'll be lukewarm yet in 24 hours. See you tomorrow. It's the next day, and what you're looking at is my beautiful milk crate full of fiberglass insulation, and that's where my part has been in since yesterday morning. We will unwrap it and see what we have. There's the piece, and where it was the hottest is where all of the fiberglass is stuck onto it. So I will have to clean that off with a wire brush, and then I'll be able to clean the piece up. Fiberglass cleans off pretty easy. Okay, so now I can take a grinder and I can clean up some of the excess weld and spatter that's on the piece. Okay, so now it's all cleaned up. You can see there's some porosity there. Don't worry about that. It's best to have as little as possible, but you're going to end up with some. It's the nature of the beast with cast iron. A couple things I want to touch on that I didn't touch on yesterday when I did this video was cast iron and hardened steel. Basically, you use exactly the same process with the preheat and the post heat, but it will weld much better than what cast iron or cast steel will weld. Don't worry about it when you run your first pass or your second pass. Consecutive passes get better and better. The first one is kind of sparkly and stuff flies and it just doesn't seem right. Well, that's again the nature of the beast cast iron. As you butter it up, as I said in the first part of the video, it gets better and better. Each consecutive pass runs in better and better. Another thing that you're going to want to do, which is key in a lot of welding, pipe welding and everything else, is staggering your starts and stops. What I mean by that is if you're running a pass in a bevel, the first one you start out and you run from here in this direction. The second one you start from here and run in this direction. You do that, you alternate those passes, so that what ends up happening is your start has less penetration and globulates more on top of the metal than down inside, and the end of the weld is burned down in and has better penetration and it's lower. So by alternating your passes back and forth, you get good penetration on both sides, and you also end up with a more even weld when you're done with it. So I got a little more cleanup on this yet, which is I have to clean up the holes with a carbide burr, and then verify that my shaft fits back through here, and then at that point in time this piece will be completed. And there is the completed piece, repaired. Rod slides through, everything fits, works pretty tight, ready to be installed.